let's do the same thing that we did in the previous example. We're going to find all four extrema types. So local extrema and global extrema. But this time, I'm not going to restrict myself to a domain. I'm going to assume that this function extends indefinitely in both directions. So the domain is going to be all real numbers. So let's find local extrema. Let's do maximums first. Where do I have points that are taller than everything else around it? So I'm nowhere on this line because all the points to the left, if I choose a point right there, then all of these points to the left of it are taller than it. So nothing over there is going to be a maximum. I see a maximum right there. So we have a local maximum at the x value of, it looks like maybe 1. And I don't have any more local maximums, right? No other point is taller than everything else around it. Let's look for local minimums. So I do have several local minimums still. I've got a minimum right there and a minimum right there. So let's say x is equal to minus, what looks like maybe -3. And you have another local minimum at the x value of, let's say, 4. All right, let's look at global maximums. Right, you're only going to have one of these. Here, erase my arrows. Here, I don't see a global maximum. There is no point that's taller than everything else, right? Because these arrows go infinitely upwards. So no matter how high I go, there's always going to be a point that's bigger than me. So this does not exist. There are no global maximums. I think we do have a global minimum, though. That y value is the smallest y value that you get, right? If I assume that these arrows extend indefinitely upwards, they never go back down again. So this right here is the smallest y value. So you have a global minimum at the x value -3.